So the next thing is factors affecting preferential discharge of ions during electrolysis. Factors affecting preferential discharge of ions during electrolysis. So the factors are: one, the position of ions in the electrochemical or activity series That's the first one. Two, the concentration of the electrolyte. That's another factor. And finally, the nature of electrodes. These are the three factors affecting preferential discharge of ions during electrolysis. So we want to consider it one by one. So let's see the position of ions in the electrochemical series, how it affects preferential discharge of ion. That is the next thing to do. The position of ions in the electrochemical series. The position of ions in the electrochemical activity series. So what do we mean by electrochemical series? Electrochemical series or activity series. Electrochemical or activity series is the arrangement, is the order of arrangement, or is the arrangement of metals and non-metals or radicals according to their reactivities. That is electrochemical series. So that of metal, we have popular scientist can manufacture a zoo and the low humid country more satisfactorily good. That's the meaning. This one represents potassium. This one represents sodium. This one represents calcium. This one represents magnesium. this one represents aluminium, this one represents zinc, this one represents iron, Fe, this one represents tin, this one represents lead, this one represents hydrogen, this one represents copper, this one represents mercury, this one represents silver, this one represents gold. That's the meaning. So as you are going like this, that is increasing reactivity. You can see it going like this, going like this. Call it increasing reactivity. This is the continuation. So call it increasing reactivities. We have potassium will be the most reactive. Here, while gold will be least reactive. That's for the metal. That's an arrangement for the metal. But for non-metals or radicals, for non-metals, we say for some Nigerian clubs bring indiscipline, organization. For some Nigerian club brings indiscipline organization. This one starts off fluorine. This one starts for SO4 2 minus. This one starts for NO3 minus. This one starts for chloride ion. This one starts for bromine. This one starts for iodine. This one starts for hydroxy ion. So as you are moving like this, we call it increasing reactivity. Increasing reactivities. Where the most reactive one will be fluorine ion or fluoride ion. That is the most reactive. While the least reactive is OH minus. This is the least reactive, while this is the most reactive. This is the most reactive, while this is the least reactive. That's the arrangement. Then, how does the position of ions in electrochemical series affect preferential discharge of ion? How do we state it? The position of ions in the electrochemical series affects the preferential discharge of ions during electrolysis. As the ions below in the series discharge, as the ions below in the series discharge in preference to the one above it. As the ion below in the series discharges in preference to the one above it because of its lower energy requirement. That is what we are saying. You will see with this example how position of ions in electrochemical series affect preferential discharge of ion. So the one that is below will discharge in preference to the one above it. So we are going to look at example to illustrate this. So And a student of chemistry must know that under mechanism, before we look at example, we have mechanism of electrolysis. Electrolysis. There are three stages. Three stages involve three stages are involved. Three stages are involved. Three stages are involved. Namely, the first stage we call it ionization. Ioni- Ionization of electrolytes. Electrolyte must ionize. Immediately after ionization of electrolyte, we have migration of ions to the opposite plate, or electrodes. Then the third one, we call it ionic discharge. Ionic discharge. This I want to see example one. Example one. Let's see electrolysis of sodium chloride solution. Sodium chloride solution using carbon or platinum electrode electrodes. We want to see electrolysis of this using platinum electrode. The first thing you are going to consider, we want to see mechanism or chemistry of reaction. Mechanism of electrolysis. We want to see chemistry of reaction here. So we make use of sodium chloride aqueous. Sodium chloride aqueous, which will give you, it will ionize. You know, the first step is ionization of chloride ion. Then you must consider water. So this one will be hydrogen ion plus OH minus. That is the first stage, ionization. After ionization, then we talk of migration. So at the cathode, let's see what happens at the cathode. So at the cathode, there are attraction of charges. So cathode is negative, so sodium ion, hydrogen ion will migrate. So sodium ion and hydrogen ion migrate to the cathode due to attraction of charges, opposite charges. So you migrate to the cathode. And at the cathode, you can see in the electrochemical series, hydrogen ion is below sodium ion. So hydrogen ion is preferentially discharged. I will say hydrogen ion is preferentially discharged due to the lower position in the electrochemical series. So hydrogen ion is discharged in preference to sodium ion because it is below sodium in the electrochemical series. So what will now happen? Let's see what will happen. Hydrogen ion is preferentially discharged. You know, this one has lost an electron. It will now gain electron to become hydrogen atom. It's unstable. Hydrogen atom combined with another hydrogen atom to form hydrogen gas. So this is the principal gas liberated at the cathode. Instead of using these two equations, you can use one equation to illustrate this. Just write hydrogen ion plus one electron to, if I know the final product is hydrogen gas. So you balance the equation. Hydrogen atom 2 2 of electron, you put 2 here, equation is balanced. So instead of using these 2 equations, you can use the one. So the gas, the principal gas, or the gas liberated, the principal gas liberated at the cathode, is hydrogen gas, a gas that gives a pop sound with a lighter strength. Is liberated at the cathode. So let's see anodic reaction. What happens at the anode? As you know, Cl minus and OH minus migrate. They migrate to the anode, because anode is positive, while this is negative. There will be attraction of charges. So for that reason, Cl minus and OH minus migrate to the cathode. Then which one is below in the electrochemical series? This is the least reactive, OH minus. So we say OH minus is discharged, is preferentially discharged in preference, is discharged in preference to chloride ion due to its position in the electrochemical series. So let's see how it will discharge. So we have OH minus, it has gained electron. Definitely will now lose electron to become OH. OH combined with more OH to form water and oxygen. It's water, OH, another H, H2, then 3. Then O plus O will now give you oxygen gas. You have 3 equations to represent that. Instead of wasting your time using these 3, just use one by saying OH minus electron. If you now lose electron as gained before, to now give the final product. You can see it's water and oxygen. Just water plus oxygen gas. So when you balance the equation here, you have 4. We have 4 here, electron. So hydrogen here is, so I can put 2 here. The equation is balanced. So you have balanced the equation. So instead of using this, just use this equation. So the gas liberated, the principal gas, or the gas liberated at the anode. The principal gas liberated at the anode is oxygen gas, meaning a gas that rekindles a glowing slate. The resulting solution contains, it will remain sodium ion, which was not discharged, and chloride ion, sodium ion and chloride ion, which when combined together will give you sodium ion plus chloride ion. So you give the sodium chloride. So the solution still remains the same. So it will contain sodium chloride. That is the resulting solution. So this, what we have done so far, can be written in a tabular form. But before that, take note of this. The reaction that occurs at the cathode is called reduction. It's called reduction. Why that of anode? Why that at the what? Anode is called oxidation. So reduction occurs at the cathode, while oxidation occurs at the anode. This can be remembered using mnemonic. We have red cards, and ox. This is what we use to remember it. So red card, reduction occurs at the cathode, while at the anode, oxidation, red card and ox. Remember the one we have just done here, where you have hydrogen ion plus electron to become hydrogen like this. If you balance the equation, this is what you have. This is gain of electron. And you know, oxidation, you remember rich and oil. For reduction is gain of electron. Electron is being gained here. If you remember, this is the reaction that occurs at the cathode, while this is the reaction that occurs at the anode. You still remember? OH minus, you put 4 here, minus 4 electron to give 2 moles of water plus oxygen gas. You can see this is a loss of electron. We call it the oil. That is oxidation occurs at the anode. That is oil. Oxidation is loss of electron. Reduction is gain of electron. So this is another way to remember that. So reduction occurs at the cathode, while oxidation occurs at the anode. Let's put it in a tabular form. Can be written in tabular form like this. We talk of electrolytes. This is sodium chloride solution. Sodium chloride solution. Here we want to see cathode. We want to see what is being used as anode, that is electrode. So you can use carbon or platinum. You can as well use carbon or platinum. Very important. So 2, gas evolved at the cathode. The gas evolved at the cathode. So we talk of hydrogen gas. The gas evolved at the anode. Say oxygen gas. Then resulting solution contains sodium ion and chloride ion, which combine to form sodium chloride. Is there any change in pH? No change in pH. Because we started with a sodium chloride, you ended with sodium chloride. No change. Is there any color change? No color change. What of concentration after electrolysis? concentration after slightly before water is being used. So slightly increases or increased after electrolysis. That is the summary of mechanism of electrolysis of sodium chloride solution. This is table of electrolysis of sodium chloride solution. That's the summary of electrolysis of sodium chloride solution.